Hey, welcome back, math friends. Today we are going to be taking a look at beginning topic 5, our journey into the world of integers. But before we can talk about integers, we have to lay out some groundwork, get some scaffolding taken care of, try to find out, get some information about new stuff that you may or may not know so that we can keep moving forward. So, here we go. Before we can talk about integers and the kinds of numbers that they are, we need to talk about other types of numbers. And our first type of numbers we're going to talk about are the natural numbers. And make sure that you copy down in your notes these 3 column notes. You don't have to draw the box that you see here. It would be fine to just draw this line here and this line here, and then copy it from there, but don't feel like you need to draw this box on your page. Please do not, as a matter of fact. So let's start with the natural numbers. What are they? So the natural numbers are the numbers that are used to count things, always starting at the number 1. Oftentimes they're called the counting numbers. And our visual representation of that, well, they start at 1. So it's 1, and then 2, 3, and 4, and 5, and so on into infinity. Those are the natural numbers. Okay? And make sure you take the time to pause the video so you can copy everything down. All right. Our next vocabulary word are the whole numbers. What are the whole numbers? Now, the whole numbers aren't all that special. It's just all the natural numbers that we just learned about plus 0. So it's like basically the natural numbers, but instead of starting at 1, they're starting at 0. So 0, 1, 2, 3, 4, 5, 6, and so on into infinity. Those are the whole numbers. The only difference between the whole numbers and the natural numbers are that the whole numbers have the number 0 included. Okay, that takes us on then to the integers, the numbers we're going to be learning about so much in this topic. And the integers are all the whole numbers, like we just learned about, and their opposites. Okay, so if we were to put 0 somewhere in the middle, then we'd have 0, 1, 2, 3, 4. How about counting right? 1, 2, 3, 4. But then down here we have -1, -2, -3, and -4. So we have all of the whole numbers, and then we have all of their opposites. Those are the integers. Okay? As you can see, they are positive and negative. And that takes us right on into our next term. What is a positive integer? Well, a positive integer is an integer with a value greater than 0. And so how would we represent this? Well, we could draw a number line. And if we were to put 0 like here, then all of the positive integers would be over here. You can see that all the positive integers are to the right of 0 on a number line, when that number line is, of course, a horizontal number line like I just showed. They are to the right of 0. And of course that means that the negative integers would be, a negative integer would be an integer with a value less than 0. So again, if we were to draw a number line, a horizontal number line, and put 0 on here, the negative integers would be here to the left of 0. Because everything to the left of 0 is less than 0. Okay? Great! We are moving right along onto the, what is an additive inverse? Oh my gosh, an additive inverse. That sounds very mathy and intelligent. It's actually pretty easy. An additive inverse is just a number's opposite. So, if For example, if you had the number 3, that number's additive inverse would be negative 3. And if the number was like, say, negative 7, that number's additive inverse would be positive 7. See, additive inverse. It's just a number's opposite. Easy peasy. All right, well, that leads us on to our next term, absolute value. And what is absolute value? That's an interesting term. And absolute value is a number's distance from 0 on a number line. How many units is that number from 0 on a number line? So let me draw my number line here. I would encourage you to do the same. Put 0 right here in the middle. And make some marks on my number line here. Okay, so absolute value, first of all, looks like this. So when you say, oh, I'm talking about the absolute value, you talk about the absolute value of negative 3. You put those bars around it. Those are absolute value bars. Now, where is negative 3? Well, there's negative 1, negative 2, negative 3. It's right here. And how far is negative 3 from 0? Well, it's 1, 2, 3 units from 0. So the absolute value of negative 3 is 3. Okay, but what about the absolute value of 3? Well, let's find 3 on the number line. Here's 0, 1, 2, 3. Here it is. How far is 3 from 0 on the number line? Well, it's 1, 2, 3 units from 3. So the absolute value of 3 is 3. Interesting. The absolute value of negative 3 is 3, and the absolute value of positive 3 is 3. Why is that? Well, because distance is always a positive number. So absolute value is always going to be a positive value. It's because it's how far is that number from 0, and 0 is the magic number. Okay, great. That takes us on to our very last term. What is a zero pair? Well, that's a great question. The answer is a zero pair is a number and its opposite whose sum is 0. So, for example, 8 and its opposite, which is negative 8, or its additive inverse, 8 plus negative 8, when you add them together, equals 0. As if somebody gave you $8 and then they took away $8, leaving you with $0. Or we could say, well, negative 5 and its opposite, the opposite of negative 5 is 5. Negative 5 plus positive 5 is 0 because they are a zero pair. And then we also have, let's say, 1. 1 and its opposite, negative 1, they equal 0. They are a zero pair. That's all a zero pair is. It's two numbers. When you add them together, they make 0. That's why they are a zero pair. Two numbers, when you add together, equal 0. How fantastic is that? Well, that's all the vocabulary we have for today and for this unit. If anything else comes up in further lessons, we'll talk about that then. Have a great day. Don't forget to be awesome. And keep mathing.